Hello guys, I'm Paul McWhorter and I am here with lesson number 11 on using Python with the Arduino. And we've got an exciting lesson today. What we're doing is we're streaming live data from the Adafruit BMP180 pressure and temperature sensor through the Arduino into Python, and then we are plotting that data live in real time in Python. And so this is an exciting lesson. We're going to get you to the point that you can do this on your own. Just to show you here that this thing really is working, if I come down here and put my finger on the sensor, you can see that my most warm finger warms the sensor up. I take it off, and then you can see in here red in real time the temperature of the sensor dropping back down. So it's just really powerful to be able to plot live data from sensors or other projects in your Arduino. And so we're going to take you through it step by step today and how to do that. If you haven't been with us on the earlier lessons, you probably need to catch up on a few of the prerequisites so you'll be up with us. You can do that by going to my website, www.techboy.com. You want to go to Using Python with Arduino. A couple of the things. In lesson 2, we show you how to install Python and we show you how to install VPython. The thing about Python is you probably want to be using the same version as me, so everything will work the same. I'm on 2.7. Okay, and then I also in lesson 2 I installed VPython. We're not using VPython today, but it does give you NumPy or NumPy, and we will be using NumPy. So you either need to install VPython or you need to install NumPy. Okay, then if you come on further down, you also need to install Matplotlib, and we show you how to do that in lesson 7. Okay, so in lesson 7 we install Matplotlib for you. So if you don't have Matplotlib, you need to install it in lesson 7. Okay, in lesson 9 what we did was we got the sensor up and running. It's real simple to get that sensor up and running, but you'll want to go to lesson 9 because in lesson 9 show you how to wire up the sensor, and then we give you some code that'll get that sensor up and running and sending that data over to your over your serial port. And so you want to do that lesson 9 if you haven't done it already. And then the final thing is that the other library that we need is a library that is called Draw Now, and that Draw Now is the magic library that allows Matplotlib to plot things live. And so if you just go through there, real simple things in these earlier lessons, you get your Python, VPython, NumPy, Matplotlib, and then Draw Now libraries installed. If you have all those things installed, then you should be able to follow along with me step by step from here on out. So let's go on back, and what we want to do is we want to revisit real quickly this circuit that we have down here for operating the sensor. You can see this is how I'm now in where am I? I am Python with Arduino lesson 9. I show you how to wire it up, and then I give you some code that makes this thing work. Well, if you were with me in lesson 9, I'm going to kill this at this point. It does not want to die, but I will kill it there. Okay. If you were with me in lesson 9, this is the program that we wrote for controlling the BMP180 sensor, and it's the code that then streams the data over the serial port. There's a couple of adjustments that I want to make here. I want to run this thing a little faster because we got a whole lot going on, and so I want to change the baud rate here to faster, 115/200. Because of all the graphing and charting and all the stuff we want to do, I don't want to be waiting for that data. I want to get the data coming in as quickly as I can. So I'm going to go ahead and step up that baud rate to 115/200. Also, what we were doing here, let me go ahead and download this and call it up on the serial monitor so you can see it. I'm hoping it'll download. Yep, it did. And then I need to change this to 115/200. Okay, this is what we did in lesson 9, and you can see that I'm reading the temperature and the pressure here. and I'm just creating a stream over the serial port. Well, this is great for watching it over the serial port, but if I'm going to be pulling it into Python, I don't want all this other stuff that is nice for a human to look at, all these strings that are telling me what I'm looking at. So I want to simplify this code a little bit, and where I come in, I just want to print very simply. I don't want to print the temperature is. I'm going to take that out, and I want to say serial print line temp F. That's good. I'm going to change that to a print line. And then I'm going to take out that string, and then what I want to do is just print a comma, okay, and then I don't want to print any of this, and then I just want to do a print. I'm going to make that a print line. Okay, so what I'm trying to do is I'm trying to get on one line a string that is the temperature in Fahrenheit, a comma, and then the pressure. And that way I'll read that line in Python all at once. And so what we do is serial print temp F, okay, serial print the comma, and then serial print line pressure. So that'll take us to the next line now. Okay, so let's look at this. So this should be a data stream at this point, and it'll be a lot easier for us to parse over on the Python side. So let's look at this. Okay, so what you can see is I've got temperature, I've got a comma, and I've got pressure. And so that's what I want. So what we need to do now is we need to go over to the Python side, and we need to read that in. There's some libraries that we are going to need on the Python side. Okay, if we are going to read from the serial port, we need to import PySerial, which we do just as import serial. Okay, so this is import the serial library. Okay, import the serial library. Okay, also we're going to do some pretty good array math, some pretty sophisticated array math, and so we're going to need to import NumPy. Okay, and you should have NumPy if you did that lesson 2, because we imported VPython and NumPy comes with VPython, but you'll need that library. We need to import Matplotlib.pyplot, and we're going to import that as PLT. And I like to import it as PLT because then that PLT is just a real simple object to work with. So we're going to import the Matplotlib library. All right, and then there is that magic library that allows us, and I think we installed this in lesson number 9, if I'm not, or lesson number 10 that was. Yeah, it was lesson number 10 over here. Let's just check and make sure that that is right. Yes, lesson number 10 is where we learned how to put in draw now. So from draw now, we want to import everything. Okay, so we've imported our library serial, which is the PySerial library, NumPy, Matplotlib, and draw now. Those are the libraries we need to make all this work. Okay, now what I want to do is I just want to go down and make sure that I'm getting that data over, because that's the first thing that we got to do. And so I'm going to create a while loop that just says while true. Okay, and why do I say while true? Well, true is always true. So this is going to be a while loop that loops forever. Okay, and so that's what I want to do. And now I want to go and I want to read the data from the serial monitor. But I don't want to read it unless there is data there. So I'm going to wait at this point. I'm going to create a while loop. And let's see, I need to do one other thing up here before I get into this. I need to create that object that will allow me to read from the serial port. So I'm going to make an object that I'm going to call Arduino data. Okay, and the Arduino data is going to be serial, because that's what we called the library. That's this library here. We imported serial, so we're going to do serial.serial, which is the function that we are going to do. And then we got to tell it where the COM data is. Where is the COM data? Well, I'm going to come over to Arduino, and I'm going to look under Tools. I'm going to look under Port, and it is telling me that for me, my Arduino is talking on port 11 on COM11. When you do this, it's probably going to be different, but whatever yours is, you need to put that here. And so mine is on COM11. And then I need to tell it how fast I'm talking. And if you remember on our program here, we stepped it up to 115/200 for the baud rate. So I need to work at the same level here, 115/200. And so this is just a little bookkeeping to create an object that I can read from the serial port. And so that serial port object I'm calling Arduino data. Okay, with that set up now, I'm going to have a loop here where I'm just going to be looping and reading the data. But now I don't want to read the data unless there's data there. And so what I want to do is I want to create a while loop here that just hangs and doesn't do anything until there's data. Well, how do I know if there's data? Well, I look and I say Arduino data in waiting is equal 0. All right, and then wait here until there is data. Okay, so what this is doing is, and always our loops here, on a loop in Python, we indicate that with a colon, just like I put a colon there. Okay, so this first while loop is going to loop forever, and then this while loop is just going to hang until there's data there. And then, so what am I going to do in this loop? I'm going to do absolutely nothing. I'm just going to say pass, do nothing. Okay, so when I get here, if there is no data, if Arduino data, which I named the object here, in waiting is equal 0, just sit here and loop. So I'm sitting at this point waiting for data to come in. As long as there's no data, I am just sitting there looping. But when there is data, then I want to come down and I want to read that data. And so I'm going to read that data into a variable called Arduino string. Okay, I'm going to read that variable into, I'm going to read that serial data into a variable called Arduino string. So Arduino string is going to be equal to Arduino data dot read line. Okay, why Arduino data? Because that was the name of that object that is connected to the serial port. So I can take that object and I can do a command called readline. So Arduino data.readline will go out and read the serial port, and then it puts it in the variable Arduino string. So I sit here and loop as long as there's no data, and then as soon as there's data, I read it. And then Arduino string is just my variable. And remember, in Python, we don't have to declare our variables, and so we just make up our variables as we go along, and I read it. I think I have just read the data. I'm going to see, though, I want to kind of run this just to see if I'm doing this. Arduino string. And so I wait for the data. When the data's there, I read it, and then I'm going to print it. And let's just run this just to see if we got something that's working. Oh, Arduino data is not defined. I have probably Arduino. I need to spell this right. Arduino. So this has to be called the same as this. And so Arduino data is what I named the object. So I need to read Arduino data. So you see, I like to run things as I go so I can find those little mistakes that I make. Ooh, still not happy. Arduino data. I'm still not spelling it right. Oh, I put that. There's that U I was missing. Arduino data. Like I told you guys, I am severely dyslexic, so it is very hard for me to not make little transcription errors like that. So let's take another look at it. I think it's going to run this time. Boom, it is going to run. Ooh, no, it's not. I'm still, I'm still misspelling this. Arduino data. Arduino data. Okay. Oh, here it is. Arduino data. So now I have them all spelled the same in all three places. I apologize for the delay, but we're going to get it this time. Okay, so look what we got now. We've got the temperature data and we've got the pressure coming in. Okay, and look at this. As I put my finger there, the temperature goes up. I take my finger off, the temperature goes down. So we are getting live data from our circuit into Python, and we're printing it into Python. I just like to get some of this simple stuff taken care of just so that I know that it's working before we get into our hardcore plotting. But the good thing is we've sort of hit a milestone here, and the milestone that we have hit is that we have read the data coming from the pressure sensor into Python. And so what do I want to do now? Well, that was like that was reading a long string. So when I do Arduino data.readLine, it just reads a string. But if we're going to plot, we got to turn that string into numbers. And so I'm going to take my print comma out here, my print line out here. So the first thing I need to do is take the long string and split it into two strings. I want to split it into the string that was the temperature, and I want to split it into the string that was the pressure. And so how do we do that? I need to create a new variable. And I'm going to call my new variable data array. And what data array is going to be is, it's going to be this variable, Arduino.string, Arduino, I'm going to try to spell it right this time, string, and then what I'm going to do is I'm going to do the function split. So I'm going to take this string, Arduino string, and I'm going to dot split it. And where do I want to dot split it? I want to dot split it at the comma because I had a comma between those two numbers. And so what this is going to do is this is going to create an array. And that array is going to have two values, and it's going to have two values based on splitting this variable at the comma. Okay, it's going to do it based on splitting that variable at the comma. And so then I think I could say print data array, and I could print data array. The first one we start counting in Python, it's 0. The first one will be 0, and then print data array 1. Okay, and then I'm just going to do a print to print a blank line, but this should print temperature and this should print pressure. And so let's look. Let's look here. Yeah, okay. So you see what I'm doing is I am printing, stop that. I am printing temperature and I am printing pressure and I am printing a blank line. And let's see if I come in and stick my finger there. Yes, it starts heating up. So we're getting our data in, and we have split this string into two strings, but it's still a string. Okay, it's still a string. So what I want to do is I'm going to take these print statements out, and what I want to do is actually put these in variables now. And so now that I can split this into an array, I want to put it into a variable. And so what I'm going to do is I'm going to have a variable called temp, and temp is going to be equal to that first string. But now I really don't want it to be a string. I want it to be a real number. So when I do this, I'm going to convert it. So this float command will take this data array, which is a string of characters, okay, and it's going to convert it to a real number, a floating point number. And the same thing here. I want now pressure, I think, I want, I'll just call it P for short, capital P. Capital P is going to be equal to float of that second string. Okay, so I wait for the data. When there's data there, I read the whole line as a string from this object, which I create here. And then once I have it read in as a string, I'm going to take that string and I'm going to split it at the comma, and then the first element of data array, which is data array 0, I'm going to put into temp, and the second one I am going to put into P. So now I should have temp and I should have P. So what if I say print temp? Okay, that's a number now, and then comma, I'll print a comma, and then P. Let's see what happens. Oh, okay, what is it? Ah, forgot my comma there. This should work now. Okay, So look at this. What is the big deal here? What the big deal is that now this is not a string 81.68, this is a number 81.68, and this is a number. So now I've got two floating point numbers that I can actually work with. I have two floating point numbers I can actually work with. And so that is good. Okay, one of the things that I want to do now is that since I have those two numbers, I want to print, I want to make a graph. And remember from our lesson on Matplotlib, when we graph things, we want to graph arrays. And so I need to create two arrays. I need to create a temperature array and I need to create a pressure array to hold those values so that I can plot them. So up here I'm going to create two empty arrays. Okay, I'm going to create a temp F. I'm going to say that that's going to be equal to an empty array. So just open bracket, close bracket, and then I'm going to create pressure, and that's going to be equal to an array with nothing in it. So I created two empty arrays. Why do I create them empty? Because the data to go in those is going to come from this data stream. And so I create them empty. And then once they're empty, to put something in them here, I can say temp F is basically what I just do is I say temp F dot append. So I take this array and I append to it what? I want to append to it temp. So the array temp F, I append to that array this number temp. So as I go through here and loop, that array is going to get longer and longer and longer because it's going to keep adding the latest temperature data to the end of the array. Okay, and then what I can do here is I can do the same thing and I can say pressure, that's this pressure array. I want to append the number, what? P. Okay, so let me just do this just to show you how this is working. I'm just going to print one of them, temp F. As this goes through, each time the array should be longer, and it'll print it out here. And it should be the temperature data. Yeah, I've got one. You see how I'm getting a longer and longer and longer list because I'm appending more and more and more data to it. So that is working. And you guys, if you're good, you don't have to go as slow as I am, but this is really sort of for new programmers. And I like to stop and make sure things are working the way I think I want them to work as I go along. And so that's why we go a little bit slow. All right. So I'll take that out. So now I have a temp F array and I have a pressure array. Okay, I have a temp F array and I have a pressure array. And so now what we want to do is we want to actually start thinking about plotting. Okay, this is the key to plotting live data. What you want to do is you want to create a function. And in that function, you want to create your plot. Like imagine you just wanted to do the plot one time like we did in lesson, what was it, lesson number 9? Was that where we did the, got familiar? No, it was, yeah, lesson number 9. No, it was lesson number 8 where we go in and sort of learned how to use Matplotlib. And remember, in lesson number 8, we could go in and we could basically create all types of different charts and graphs. Okay, well, what we want to do here is we want to imagine we were just creating one chart and we want to create a function that would make that one chart. So I want to find a function. I know we haven't talked a lot about functions, but basically you create a function by just saying define. That means I'm going to define a function and then I'm going to make it give it a name. Well, what is the function going to do? The function is going to make a fig. Okay, make a figure. You could name this whatever you wanted, but now if I call make a fig, it will do everything that is defined here, and we don't pass it any parameters. And this is sort of like a while loop or a for loop. You put that colon there. So what we are going to do here is we're going to create a function that makes our desired plot. Okay, so this is just going to, inside this function is where you're going to do this. I need to be a good boy and I need to go back here and put some comments in here. And so what were we doing here? We read the line of text, okay, from the serial port. And then what did we do here? Okay, we split it into an array called data array. And then what did we do here? We convert first element to floating number put in temp. Okay, and guys, you really got to do your comments, because I'll forget what I'm doing if I don't do my comments. Okay, what do we do here? We convert second element to floating number and put in P. And then we are going to build our temp array by appending temp readings. Okay, and then what we are doing here is we are building our, and this should have been our, building our pressure array by appending P readings. Okay, so now we've got our comments in. I'm sorry, I should have been doing that as I went along. And then what we are doing here is we are creating our serial object named Arduino data. Okay, and so we've got all that bookkeeping taken care of. And so now we are going to make our function, and this function is going to be a function that would just, if you just did it one time, it would just plot a figure. And so what we are going to do is we're going to call this function make figure, and then let's do something relatively simple at first. Let's just plot. Let's see how simple we could make this. Let's just plot. What would be the simplest thing to plot? What if we just plotted our temperature? And remember, our temperature variable is temp F. What if we just plotted that? Just plot, and that's not. I need to put plot.plot, and this PLT is because we imported this as PLT and we tell it what to do. We want to plot, and all I'm going to do is just try to plot this temp F. Okay, and so I think that that would probably be about the simplest thing that I could possibly do. Okay, and then I need to come down here, and what I need to do is I need to call that function that would plot that. And so what I need to do is I need to say draw now. Remember, that was that library. And what do I want to draw? Okay, I want to draw now this function up here, which was make fig. Okay, like that. And so when it comes here, it says draw now. Draw now. What make fig? What's make fig? Well, it's this. All right, there's one other thing that you have to do to plot live data, and that is up here at the top, you have to tell it that you are going to be plotting live data. Tell Matplotlib you want interactive mode to plot live data. Okay, and I hope this isn't too confusing because it's really pretty simple. So we import our libraries. We're creating an empty temp F array and an empty pressure array, and then we create our serial object, and then we say, hey, Matplotlib, I want to plot live data. Okay, then we create the function that is the plot that we want to create. Then we're going to loop through here, reading data, and then calling draw now to go out there and plot the data live. Okay, and so I'm just going to run this and find out where all my mistakes are. Okay, convert, it doesn't like data array 1. Convert second element. Looks out of range. Okay, it doesn't like that. So what did I do wrong there? Float data array 1. We split this at the comma. float is equal to data array 0, data array 1. Let's try this again. I'm not sure why that's not right. Okay, sometimes like you just get a bad read, and I probably need to go in and I probably need to put some error trapping in there, but it just got a bad line and we were just sort of unlucky there. Okay, and I should not have done that, and I know what I did wrong. Okay, after you do this, and so now let's put our comment in here, and then we're going to put our comment, and then what this is, call draw now to update our live graph. All right, and then what you got to do is after you do that, you got to plt.pause just for a very small amount of time. This is like 0.000001. And if you put that pause in, then it gives you a chance to move things around. It's just sort of a little quirk about this draw now. After you call it, you need to pause, plot.pause for a very small amount of time. This is going to work. And also the thing I saw that I didn't like was on our plot, what I want to do here is I want to kind of tell it what I want to plot, and so I'm going to go like a red, I think I want a red dot and a red dot, so R0 and a line, and then like that, and so now I should get a little dots and a line coming across. So this says I want it red, that little O says I want dots, and that says I want a line. So now let's run it. Okay, look at this. We are getting live data now. Look at this. We are getting live data graphing. It's the temperature. What if I come over and put my finger out? Whoa, look at that. Take my finger off. We get the nice exponential decay of temperature like we would expect. All right, we have got the basics working. So I hope this wasn't too confusing and it doesn't want to die. We got to kill it from the shell. I hope this wasn't too confusing, and I hope if you look this, you could now make it go do the things that you would want to make it do, okay? You could go make it do all the things that you would want it to do. So what do? We import our libraries. I create empty arrays. I create my object for reading the serial port. I tell Python that I tell Python in Matplotlib that I want to plot in interactive mode. So interactive mode is on. I've got to tell it that. I've got to create this function that inside this function would be, imagine you just wanted to make a plot one time. This is what I would do. Okay, so all the things associated with how you want your plot to look, you put here. I did this just the simplest thing just to show you how to get the pieces working. What do we do now? We create a loop that loops forever. What do? We wait here until we get data at the serial port. When there's data at the serial port, we read it. Then we have it in Arduino string. We split that at the comma into an array. The first value in the array is temperature. The second value in the array is pressure. We do float so that we convert the strings into real numbers. Then we built up our temp array and we built up our pressure array, and then we tell draw now to go out and do that function, make that figure, and then we tell it to pause. Okay, this is pretty exciting. Let's take a look at this again. Okay, let's just take a look at this again. All right, so here's my data coming in. Let's see if I put my finger. Look at that, it heats up and then it goes back down. Okay, one thing that you can see that is going to be a problem, if we sit here, this just continues to add more and more and more data. Okay, it's adding more and more and more data. And so what happens if, I'm not going to sit here for an hour, but what if we sat here for an hour? All of a sudden the data is just so scrunched up. If I did something like put my finger on it, it gets to where I can't really see the details because I'm getting all this old data that I don't want. You see, what I care about now is I care about what's happening now, or I care about what's happening in the last few minutes. I don't want all of this old data. What if this thing ran for 3 days and then I would have all this old data to where really what I only cared about is I only cared about the new data. And then it starts getting to where I can't really see any detail on my new data because I have so much old data. So what you would really like is you would like to, I mean, when you're doing this charting type of stuff, you would really like to be able to just plot like the last 50 points, or just plot the last 100 points, or just plot the last 25 points, okay? And let me show you how to do that, because this is something this is business we got to take care of right now, because before we really go on, you can let it plot all the data if you want, but in almost any of the things that I can imagine, you wouldn't want to plot all the data. So what can we do here? Let's find a little place here. Let's make a counter up here so we sort of know how many times we've done that. So I'm just going to say count is equal to 0. So I'm creating a counter. And then down here, I'm going to say count is equal to count plus 1. And then what if count is greater than, I'm going to keep the last 50 points. So if count is greater than 50, what do I want to do? If count is greater than 50, what I want to do is I want to get rid of the first element in the array, because the first element in the pressure array, or the first element in the pressure array, or the first element in the temperature array, temp-F array or pressure array, the first element is the oldest one, and I want to get rid of the oldest data point, okay? And so how do I just take that array and just kick out that first element? Well, what I do is I say temp-F, I want to pop out the 0th element, because that's the first one. Pop says kick it out of there, and everything scoots down one. So if I have an array of 50, it takes the first one out, which is the 0 element, and it scoots everything down by 1. So I want to pop out of there that 0 element, and then I want to, what's my other one? Pressure. I want to dot pop out of there the first element. Okay, and so now let's run this and see what happens. Okay, so at first it looks like it did earlier. It's just building my data up. Let's come in and see. Look at that. Yeah, okay. And so I'm at 30, 35, 40, 45 data points, 50 data points. But then look at this. It doesn't get more data points. It starts moving my chart to the left. And so now I am losing that old data. And by losing that old data, what that lets me do is that lets me get a nice clear picture of the new data that is coming in. Now, isn't that slick? Here I'm just plotting the most recent data. And you can plot, like I'm plotting the last 50 points, you could plot the last 100 points, you could plot the last 500 points, but it's right in here. It's like, how many do you let build up before you start popping it out every time, popping that first value out? And I said 50. If you said 500 here, it would go to 500. Let me just show that. Let me make it the last 10. And so this will be kind of crazy because we're not keeping much data here, but let's just do it just for fun. Okay, so I'm just keeping the last 10 data points now, and so you see it's really very responsive because I'm just keeping the last 10 data points, but it's actually kind of like too fast because you're just keeping so few data points, you're really not getting a very good view of things. And so what I normally like to do is I normally like to keep about 50 points, okay? And so that works pretty well. So wow, that is pretty neat. What are some things that I did not like very much about that? Well, on my figure, I didn't like how it kept rescaling things because it was confusing to me when it kept rescaling things. And so what I am going to do here is I am going to kind of set the axes so it doesn't just keep doing that. And so what I am going to do to set the axis, I'm going to say plot, and then I'm going to say y limit, and that'll set sort of the y limit, the y min, and the y max. It's about 80 degrees in here. So I'm going to say the low end is going to be, let's say 70, let's say 75, and then the high is going to be 85. Okay, so I want to set the limit on my y-axis to go from 75 to 85, and I want it what I want it. I don't want it to be rescaling for me, so I'm going to set that. Okay, what else am I going to want to do? I am going to want to put a label on here. Remember how we could put a title, so I'm going to say plot.title. Okay, and then what am I going to call it? My live streaming sensor data. And why? Because I don't want to call it temperature at the top, because remember in a minute we're going to plot pressure as well. So I want to plot pressure and temperature. So I'm just going to call this my live streaming sensor data, because that, you know, that will be good for both things. You know what? I always like to put the grid. I like to have the grid, and so I'm going to put the grid as true. So in this function, I'm doing everything just as if I was just going to plot it one time. And then I'm going to put plt.ylabel, and I'm going to put that as, let's say that what would be a good label, I'm going to call it temp F, so that I know that it's F. So let's take, like that. Let's take a look at this and see how our graph looks now. Okay, there it is. Look at that. My live streaming sensor data, temp F. I think I'm going to come out to 50 points. And then it doesn't change. And then if I come in here, and one thing is that you can see that it's about 80 degrees in here, and so I'm going to go ahead and make it 80 to 85, because that would be a little bit more suitable for the range that we have. Okay, so let's go ahead here, and I'm going to go on my Y limit from 80 to 85. All right, and that should work a little bit better. I want to put a legend on here, and remember how we put a legend? I'm going to put comma, and then what do I say? Label is equal to, and then what should my label be? I think my label should be degrees F. And so that's the little label that it'll put on the legend, and then I need to tell it to plot the legend, so I'll say plot legend. So I want it to show the legend. And I'll show you something else too. I can tell it where to put the legend. I can say location is equal to, I think, upper left. And so you could do kind of the possibilities: upper left, upper center, upper right, probably lower left, lower center, lower right, and maybe you could even do like center center or something like that. But these, I know, let me put it where I want it. So let's look at this chart now and see what I can get. Look at that. Just like I told it, upper left, degrees F. Then I have temperature F. I'm going to get 50 point. My live streaming data. And is it live? Yes, ladies and gentlemen, it is live. Okay. And look at that. I might even need to go like 80 to 90, because my warm finger makes that thing really go up when we put it in there. Yeah, I think I'm kind of particular about these things. I'm going to make it 90 and see if that runs a little better. Okay, let's run it. Okay. Now if I come in and I touch it, yeah, now I feel under pressure to get the temperature up there higher. Okay, yeah, all right. And so then I take it off and it comes down. And look at that. I just love it how we're there at 50 points and I can see the last 50 points, and then I can see that kind of nice exponential decay as the temperature comes on down. And so this is looking good. This is looking wonderful. Okay, so now I like all that stuff about it, but I think the other thing that I am going to want to do is I think that I want to plot pressure and temperature. So how would I create a second y-axis? Because I can't print pressure in pascals, which is like 97,000 or some crazy number like that, on range from 80 to 90, so I need a different scale. I need a second y-axis. The way you can create a second y-axis is create it as like PLT2, and so I can create this object PLT2, and I can say, what is that? That's PLT.twinx. And so what I want to do is I kind of just want to create a twin of the PLT. So this is all the PLT stuff. I want to create a twin of it that I'm going to call PLT2. And so if you don't understand it, don't worry, just do it. Now I have a new object called PLT2, and I can do all the things that I did before. And so let's say I take PLT2, and what do I want to do? I want to plot. And what do I want to plot? I want to plot pressure. Okay. And I'm going to give it a, let's make it blue, and let's make it little dots. And then let's do something different. Let's make it triangles. Shift 6 will make it triangles. And then let's make it a line like that. And then make it like that. And now I should get two data streams coming through. The suspense builds. Oh yes, look at that. Okay, so here's my temperature and here's my pressure. Okay, if I touch it, I change both of those. Okay, because you can imagine I'm pressing the top where that little hole is, and I'm changing the pressure in there. I'm getting live streaming data. I'm getting live streaming data of temperature and pressure, and I just really love that. Okay, so temperature is working great. I love that. And you know how I set the scale on temperature? Well, the thing is the pressure is kind of keeps rescaling and doing this goofy business. I like to set the scale. I don't like auto scale. So I need to go in and I need to set that scale on that second y-axis because I don't like this auto scale nonsense. So on this one, let's come in. Let's say plt.ylimit, and I probably should have looked at the values. I guess I could just try 90,000 to 100,000, and don't put commas in here because it, okay, 90,000 to 100,000, and then we'll look and then we'll come up with a better range because you want to tighten that up a little bit. Okay. So let's say it's between 92,000 and 94,000. You know what I just need to take a second here, and I probably just need to print, big P, and that way let's just look at it and then maybe better figure out what the range should be. Okay, so it's 93,500, 93,500, and if I go up, it should go down. So probably 93,500 to, I'm putting it down low now, 93,525. I'm sorry, but we got to get our scales right. Okay, so that would be, and you know, if you're running this for days, you would want it much greater range than this because the barometric pressure is going to be changing. But over a short time, I want to be able to look at those little short-term variations. And so I'm going to go from 93,500 to 93,525. And that's going to set my range there. Let's go ahead and give this a label while we're at it. Okay, label is equal to pressure in pascals, like that. And Pascal was a person, so we will show due respect and capitalize his name. Okay, so label is pressure Pascal, the string, and then I close that. This should put the labels on there. Okay, so if we look at this now, this is not auto-scaling, and so that's good. And so even though it went off range, it didn't auto-scale. The temperature is behaving beautifully, and the live streaming data is looking good. I got this legend, but I didn't get my other legends. So let's see why I'm not getting my pressure legend. Okay, to get my pressure legend, you see I said plot legend. I plotted the legend for PLT, but I didn't do the PL2, my second one. So PLT2, what do I need to do? Dot legend, okay, and then LOC equals upper left. Why would that be stupid? That would be stupid because it would put it on top of the other one. Okay, we don't want it on top of the other one, so let's say upper right, and that should put it in the upper right. Okay. Okay, look at that. I've got my legend here for the blue. I've got my legend here for the red. I come in here and things update and things change just like I want them to. Look at that. So this is just really, really great. This is doing exactly what I want it to. Okay. Now, what is it that I don't like about this? Well, what I don't like is, notice how Matplotlib decided to rescale this with this goofy of like plus 9.35 e to the 4. I mean, this is crazy. Don't rescale this. Okay, don't rescale this. If I want to put a scale, I'll scale the data and I'll do the scale. But one of the interesting quirks about Matplotlib, it's very, very hard to get it to not do this goofiness when you start dealing with big numbers. It doesn't have a good intuition for big numbers, and so we got to force it to not rescale the y-axis. So I will kill this, and with a little luck, I will show you how to do that. And one thing is I need to take this print statement out here that we put, right, because we don't want to print this anymore. That was just to debug. Okay. What I think we'll do this will be if we come in and right when we've created this plt2.object, what I want to do is say plt2, and what I want to say is dot tick label underscore format, and then use offset equal false. And with a little luck, what this is going to do is it is going to say on the tick label, don't do an offset. And I know this is kind of crazy, but this is just one of those things that if you know this command, usually it will work. Force Matplotlib to not auto-scale y-axis. Okay, and this is let's just put some comments in here. Okay, what are we doing? We are set y min and max values. Okay, and what are we doing here? We are plot the title, and then what we are doing here is we are going to turn the grid on. And then what are we going to do here? We are going to set y labels. Okay, and then we will plot the temperature, and then plot the legend. This, I'm sorry, but it's just we really got to be good about this. Okay, what this did was create a second y-axis, and then what we're doing here is to set limits of second y-axis, and then what we are doing here is to plot the pressure data, and then we are doing the legend here. So we will plot the legend. Okay, so now let's run it and see. We might have to still tweak it a little bit. Okay, look at this. Now I have the number without any goofy offset for the pressure. And then my temperature is down here. So let me see what happens. I come up here and look at that. That goes up, and then I take my finger off and it comes back down. Well, look at this. Okay, so with that, that went a little bit high, but that's okay because that was artificial with me sticking my thumb on it. That's not kind of the natural thing that you would want to do with your pressure sensor. But let's see if we can actually see pressure. So what I'm going to do is I'm going to take this, my little handy dandy circuit, and I'm going to come over here and let's see if you can watch me and watch the data. And so watch that pressure. What's that pressure data? Okay. What should the pressure do if I lower the circuit? The lower you go, the more air there is, and so the pressure should be greater if I lower the circuit. And so I'm going to put the circuit on the floor, and look at that. Look at this. You can see the pressure dropping. I put it down lower by about 3 feet, and that sensor picked it up. Let's see if I go up here high, the pressure should go low, right? If I bring this up about 6 feet, that pressure just about goes off the scale. And then when I bring it low, it comes back. And then when I put it here on the table, it is in the middle. And so that is pretty incredible. And you can see that I've really got a very sensitive scale here. But the neat thing is that I can clearly see a difference of about 6 feet. I can see a difference of 3 feet with this sensor. Because let's look at this. This is averaging about 93,510 here. And then I'm going to go down to the floor with that sensor. And when I go down to the floor with that sensor, I can see that goes from 93,510 up to, probably about 93,515. And so I can definitely see a difference. I hold it up and that pressure drops. So we have an incredibly sensitive pressure sensor here. We are so sensitive, in fact, that we are seeing differences of a few feet. Okay. Now, what are some things that we could do here if we really wanted to do this? Probably one of the things we could do is we could come in and make our measurements a little bit faster and then average them. And that would probably get rid of a little bit of this noise. But wow, that is really neat. Come in with my finger again on temperature. Watch that go up. This is just absolutely incredible. So we have learned a lot today. We have learned that I did not put a y-axis, a label on my second y-axis, and so I'm going to go in and do that just because I can. And so I need to come in and I need to say plt2 dot y label, and I'm going to call that pressure in pascals, like that. Okay, label second y-axis. All right, let's run that again. This has been a long lesson. I'm sorry, guys, but there was just a whole lot of stuff that we had to learn on this one. And I got one of those bad data reads. I'll show you later how you can put traps in there. It's like if I get in the middle of a, oh, well, no, that is wrong. So what did not plot to y label? Okay, plot to label second y-axis. Oh, okay. On this one, the way that we have to do this, I think, is because this is a second one, this is a little quirky. If I remember, I have to do a set y label because this is the object that we created. The command is a little bit different for PLT2. That second one, this should work though. Okay, so I can't go in, and there you can see you got the label. I can't go in and explain all to you, all the, I can't make you a master of Matplotlib, but some of the things you just kind of pick up, and that is that when you have a second y-axis, this is how you set the label different than the first one. Okay, so this is just pretty incredible. We've got two streams of data that are coming from the Arduino. We're plotting them both live, and we have complete control of our graphs. This is so much better than those silly packages that you get like National Instruments LabVIEW, where you fill out charts. Here, when you program it up yourself, you can make it work exactly the way you want it. This has been a really important lesson. This has been an incredibly fun lesson. It's one I enjoyed. It's one I hope you enjoyed. You guys think about subscribing to my channel. Okay, think about subscribing to my channel. Maybe give me a thumbs up on the video. All right, we will see you tomorrow, and on tomorrow we will be doing lesson. We will be doing number what? We will be up to lesson 12 tomorrow. Okay, take it easy. We will see you tomorrow for lesson.